Good morning. Today I am going to talk on quantum mechanics, which is in the syllabus of MacOut and for the BTech level student and the second year. Now the course code is PH401 under physics. Under the module 5.2, this contains quantum mechanics, and this lecture is delivered on behalf of the Department of ECE at IEM, Kolkata. Now, it is really difficult, and it matters and concerns every teacher to introduce a new subject in the class. And especially, it is much more difficult if the subject content is against the common sense of the prevalent science, prevalent physics and knowledge. So really, I feel at the starting point some embarrassing that how to introduce this subject, which is at the first glance, it may seem to all of you it is unbelievable. All the things which I will tell you right now, it will go against your common sense and common knowledge with which you are well accustomed in physics. Well, to introduce this quantum mechanics subject, let me talk about the era of in between the 1900 to 1925. Like that. Now, before 1900, the ideas in physics were very strongly supported by the then principles, the then formulae, as announced by the stalwart physicists like Isaac Newton and others. All of them had the valid experimental truth. Nobody could deny that. In the year of 1900, the experiment was on blackbody radiation. This blackbody radiation is the radiation coming out of blackbody. It was an experiment. The spectrum of the blackbody radiation, when it was analyzed, it could not be explained by the then idea which was prevalent in the then physics. Debye, Albert Einstein, all the stalwart physicists tried hard to explain the blackbody radiation with the idea, prevalent idea in physics. But it could not support the experimental observation of this blackbody radiation. And finally, it was Max Planck who actually was the Nobel laureate for this proposition. He explained this blackbody radiation on the standpoint of completely new idea in physics, which goes against the then idea, the principle underlying physics. What is that? It was a belief, and a strong belief, that energy between a system and its surrounding, the energy exchange is always continuous. The energy may take any value. A system is here, the surrounding is here. The system is exchanging energy with the surrounding, surrounding is exchanging energy with the system. The energy can be any value which is continuous. But what Planck told to abort this idea. This idea is not correct. It cannot support this blackbody radiation. What he proposed, that the energy exchange is in discrete fashion. I mean in quantum fashion. Quantum means discrete. So 1, 2, 3, there is no number between 1 and 2. 1, then again the discrete 2, another discrete 3, it jumps like that. So this energy exchange is quantized, and this energy is coming in the form of the energy E. This is equal to h nu. This is the energy. H is a constant, which is Planck's constant, and nu is the frequency of radiation, the radiant energy. Now see, therefore, 1 h nu, the first energy, the minimum energy. Below 1 h nu, no energy is there. It is against the classical idea. Next comes jump from 1 h nu to 2 h nu. There is no energy between 1 and 1 h nu to 2 h nu. Then again jumps. So this is the energy exchange is quantized. So that is idea and a blackbody radiation, and it was beautifully explained. Now see that the classical physics, it does not support this quantum idea of the energy exchange. So first clash, but the classical physics and the new physics, which is, I am giving the name quantum physics. Now, with this idea, another experiment, the photoelectric effect. So this is your blackbody radiation. I am giving another example, photoelectric effect. Again, it was tried to explain this effect from the then prevalent idea in physics, the principles in physics. Nobody could explain. Albert Einstein succeeded, accepting the idea of the quantum energy. I mean like this, E equal to h nu. Yes, that energy is always exchanged in a quantum form, not in a continuous form. So look how the idea of the quantum idea is coming, and it is replacing the continuous energy. So what is this? The photoelectric effect is actually that the light beam is coming on a metal surface or any alkali metals. So this is light, and electrons are coming out. So when the light hits the surface emits the electron. This is a photoelectric effect. It could not be explained by simple the then idea prevalent in physics. So again, this is a jerk in the principle of the classical physics. Now one very interesting, another example. Yes, I think that these examples will create you the interest that why quantum mechanics, why this new subject is coming, why not we are catching hold of the classical physics, because the classical physics unable to explain all these things. I am giving another example, atom model. See the experiment. It was assumed like this, that in an atom the nucleus is at the center, the positive charge nucleus, and the electrons are rotating around this proton. Now look here, that there is a distance of separation. This is the minimum distance of separation between the proton and the electron. The proton is positively charged while electron is negatively charged. Should you believe it? If you catch hold of the idea of the physics, the Dane physics? No. Because you see that the positive and negative, there will be attraction according to Coulomb. So why not the electron is just falling into the pit of this positive charge? Why not it is being attracted? It comes and it keeps a separate distance, minimum distance here, the radius. See, it was the crux of the problem, very serious problem. See that the strong principle in physics, that is the positive charge, negative charge, there is attraction, it fails here. Why this attraction? And again, to explain this existence of the attraction, it was told that, well, it is rotating. So there is a centrifugal force. See, all these things are the classical ideas. So centrifugal force is there, and this centrifugal force is being balanced by this attractive force. See, attractive force is this and the centrifugal force is this, so it is stable. Fine, agreed. Now again you ask question that when the electron is moving, then it has some acceleration because the velocity is changing. The speed is not changing, but the velocity is changing. Why? Because the direction is changing always. Instant way, the direction is changing, that means the velocity is changing, that means there is some acceleration. So the electron is under acceleration, and again, accelerating electron according to the then classical physics idea, and strong mathematical support is there, it should radiate energy from its own body outside. So you see that the electron, it radiates energy. What will be the result? The result is the radius will gradually shrink as it radiates more energy, and ultimately it will collapse with the nucleus. So the stability of the atom structure is destroyed. No atom should be there in the universe, no molecule should be in the universe. That means no creation. The material world will be finished because there is no existence of the atoms. But it is not so. But you look, there is matter, there is atom. So you see that if you accept the ideas laid in physics at that time, then you see that the stability is jeopardized. The stability you cannot explain. It is unstable. So in order to match it with reality, real picture, that means it is in the stable orbit, some proposition were made. It is a proposition.